10 days to my due date, but, you know, you can go late, so, you know, I might never have a baby.
Parker early or late?
I have a week early, but they induced me, so. And he was 9 pounds, so I'm kind of hoping I have this one early.
Is that why they?
What? My blood pressure was high when I went to the doctor, and so then they said, we think we should induce you.
So who's your next doctor?
Induce. Induce. Induce means they give me drugs to make me start having labor. Not seduce me. That would be kind of weird. Justin Baumgartner, I feel you know nothing about babies. You think this is fake. You think the doctors seduce me. Like, it's kind of weird. Monday.
Monday? So they might say, you know what?
They might, but as long as my blood pressure's okay, they're just going to keep making me wait, so. I don't know. I really don't want to be induced because I'd like to actually be in labor on my own because they say it goes faster. So I was in labor for like 30 hours with Parker.
That would suck. Gosh, 30 hours? Do you have a TV or anything there?
I think there was a TV in there, but I don't really think I was watching it, so. Let's look at number 16. Hopefully maybe you started number 16, right? Like, did you change tangent and secant maybe in terms of sine and cosine? I think that's a good choice. Why? Because this has sine and cosine on it, and I can change both tangent and secant in terms of sine and cosine. So tangent is the same as sine of x over cosine of x, and secant is the same as 1 over cosine of x. You started over here? What did you do over here?
Literally, you don't even want to.
I want to do 16 because it's one that I think is not like one we've done before, and you're going to see it show up again, maybe on a worksheet that you're going to have again today, and I want to show you some ideas here. But what would be another good step to do here? Yeah, put them together. That was a big theme of yesterday, common denominators. If I have two separate fractions and I want to add one fraction, probably I'm going to get a common denominator. Well, the nice thing is this is already a common denominator. Do you agree with that? You can write this as sine of x plus 1 over cosine of x because they already have a common denominator. And I feel like you should be able to get to that point on this problem. But then it becomes kind of a difficult problem because you can't replace anything that's going to equal that. They definitely don't equal each other.
I know there's a little bit of discrepancy.
There's a big discrepancy.
I just check off and say done.
Yeah, that's not good. Here's the new thing that we haven't done in a proof before. We're going to have to introduce something new into this problem in order to make one side equal the other side. And how do I know to do this? I have sine of x plus 1, or do you agree that that's the same if I wrote that as 1 plus sine of x? Do you agree those are equivalent to each other? And over here I have 1 minus sine of x. There's no way I can change a 1 plus sine of x into a 1 minus sine of x without adding something to that problem. And so this is where it's a new trick that we haven't done before. Could I multiply this by something that would turn it into a difference of 2 squares? What would be the factor I would need to add into this problem to make that a difference of 2 squares? Yeah, and I switched it around because I want it to match up with this side. 1 minus sine of x. And you might say, well, how in the world can you just multiply by 1 minus sine of x? Here's how. What if I multiply the top and the bottom by 1 minus sine of x? Have I actually changed the problem? Just like if you multiply the top and the bottom by 3, 3 over 3 is just 1. If I multiply the top and the bottom by 1 minus sine of x, then I haven't changed it, I haven't broken the rules, I didn't do anything to both sides. But this is the first time we've seen a proof where you have to introduce in something new. And my advice to you is, when do you do that? When you get to something like this, and you're like, there's no way I can get there. There's no way I can turn this into this. Or if you see that one's a positive and one's negative, that's what you're going to do. And notice I turn this around so that when I FOIL this out, it'll match up perfectly. This is a squared minus b squared, so it's just 1 minus sine squared x on the top now. Because I took this times this. Right? Difference of two squares. And on the bottom, I'm not going to multiply that out because think about what I want. I want a 1 minus sine of x on the bottom, so I want to keep that together. And by doing this one extra step, maybe you can see what's going to happen here. Because now we can do some more simplifying. But that's where this one was a tough one, because we hadn't done one like this yet. But now on the top, if you have 1 minus sine squared of x, what can you replace that with? Yeah, that is a Pythagorean identity, because now it's squared, cosine squared. So now I can write that as cosine squared x over 1 minus sine of x times cosine of x. And again, look at what we have, look at what we want. Can we get there? Can we get to that final step? Yeah, if I have a cosine squared on top and a cosine on the bottom, and that's multiplication, I can cancel one out. So I can cancel out this cosine with one of those cosines, and I do have the proof finished now. That's cosine of x over 1 minus sine of x equals cosine of x over 1 minus sine of x. I thought this was the only one they had to do that on. On the next one, I just changed them in like the one we did in our notes. Like I changed all the cosines to tangent, like 1 over tangent, and got common denominators. Or you can work on the other side and change all your tangents to 1 over cotangent. That's what I would do. Like it's a bunch of common denominators. You could have worked with the other side also on this one. Like if you would have multiplied this by 1 plus sine of x, it would have worked out the same way. But the only way that I know to do 16 is to introduce that factor in that makes a difference of two squares. And so that's kind of a new one that we haven't seen before. But I believe there's at least 1 or 2 of those on the worksheet today, so that kind of leads into that. Want to look at 45? Everybody get anywhere with 45? I started 45 trying to get a common denominator of tangents and cotangents, and then I got to where nothing worked. Like I just got a big mess. And so I started over, which is why I recommended to you yesterday to start by changing those to sines and cosines, which just also makes a big mess, but that's the only way that I did this one.
So you're saying that if I got some,
Well, I didn't know where to go with it. Like I started it, and then I got somewhere, and nothing worked. I couldn't simplify anything, which is why I told you yesterday at the end of the notes that was my suggestion, is to change it to sines and cosines.
well, I did. I forgot.
So maybe we will work out to be the same thing, but because at first I thought I would just get a common denominator and I would FOIL it out and it would work, but I just got a big mess and nothing went together. Tangent squared and cotangent squared don't go together. So I changed everything to sine and cosine, which makes a whole lot of fractions. So I did sine of x over cosine of x over 1 minus cotangent is cosine of x over sine of x plus cosine of x over sine of x over 1 minus sine of x over cosine of x. And just for this one, because it's really long and it's going to take us a while, I'm going to not rewrite this one. On a proof, on a test, on a quiz, you need to rewrite what it equals every time. Like that's part of the proof process. But on this one, it's going to take us a while. So let's save ourselves a little bit of work. And I'm going to not write what it equals over here. But again, the big theme yesterday was common denominator, and this is a great one for common denominators because I'm going to get a common denominator for each one of these denominators. So that was my next step. become sine of x minus cosine of x all over sine of x. And the same thing over here. Cosine of x over sine of x. Only this is going to become cosine over cosine. Again, you got to start recognizing when to do a common denominator. And anytime you see two separate fractions, probably you want to get a common denominator. But this one's going to be cosine of x minus sine of x all over cosine of x. The point of getting a common denominator, especially in a complex fraction, is that hopefully you can then multiply by the reciprocal. You don't want to do that when you have a bunch of addition and subtraction because you're going to get things mixed up and cancel things out that shouldn't be canceled out. But if you can write one fraction all over one fraction, then you can multiply by the reciprocal. And so that was my next step. I'm going to flip those up so that I don't have such a big ugly mess anymore. Well, maybe. I'm going to write that as sine of x over cosine of x times the reciprocal of this, which would be sine of x over sine of x minus cosine of x plus cosine of x over sine of x times the reciprocal of this, which is cosine of x over cosine of x minus sine of x. And although that's a whole lot of stuff, it definitely got rid of the complex fraction. It would have been really nice if something canceled out here, but it doesn't, which is what makes this super great proof. So I'm just going to multiply those, multiply the tops. I'm going to leave the bottom like just not multiplied out. I'm going to write it with parentheses. So on the top here, I get sine squared x. And on the bottom, I get cosine of x times sine of x minus cosine of x. And over here, cosine times cosine is cosine squared. And again, I'm not going to multiply out the bottoms, because if I multiply out the bottoms, nothing's going to cancel. It's just going to be a big mess. It would have been bad enough if this proof just started right here. Like this, they could have given us this as a starting point, and we still have a good amount of work to do. But it took me a while to get here, and I would be interested to see if someone used tangent and cotangent and got something to work out, because I just started a few steps and didn't see it going anywhere. So that's why I went this route. Interesting.
But I didn't think it, like, I looked at it to see if they could help me start it, but I didn't understand why they didn't multiply sine.
Yeah, that's weird. I haven't even looked at the back of the book, but I think, did they use a difference of cubes at some point?
I think so.
I do too. I think, so apparently they started a different way, but ends up kind of with the same mess I'm feeling, because we're going to get there in just a minute. What do you think is the next good step on this? If we distribute the bottom here, you're going to get sine of x times cosine of x minus sine squared. Nothing's going to cancel there. So if nothing's going to simplify out, my advice is don't distribute. But if you have a fraction plus a fraction, what should you be doing? Another common denominator. Yeah, kind of awful, right? I think they're pretty close. Do you agree with me on that? That this and this are almost the same. Do you agree with that? What could we do to make them the same so that we don't have to have that whole thing as our denominator, like three separate things? Could I pull a negative out of this? And if I pulled a negative out of this, do you agree that that would make that sine would become positive and cosine would become negative? So I could rewrite that as sine of x minus cosine of x. But I need to pull a negative out of that, so I just changed this from a plus sign to a minus sign to pull a negative out, because I want to do the least amount of work possible. So it'd be really nice if those were the same. This is about the time that I wrote wow next to my paper. But if I do that, again, I'm kind of just putting that underneath here. Now the common denominator isn't as bad. I have to take a cosine. Do you agree with that? I have to take a sine, so I have cosine of x times sine of x. But because I pulled the negative out, I only have to take one of these now instead of two of them, which makes things a lot better. And this is my common denominator. So now the question is, what do I have to multiply over here to get this new common denominator? What am I missing? Just a sine, because I have the cosine. I have the sine of x minus cosine, so I just need a sine. So I'm going to multiply this side by sine, and sine times sine squared gives you sine cubed. And over here, I have the sine. I have the sine minus cosine, but I need a cosine. Don't forget we took out that negative, so now it's minus cosine cubed x. And then, this is why I gave you this on your notes yesterday at the end of your homework, because this is a difference of two cubes, and if you factor it, then you're going to be able to get stuff to simplify. And so you have to remember that when you factor a difference of two cubes, that's going to factor into a minus b times a squared plus ab plus b squared. So for us, a is sine and b is cosine. So this factors into sine of x minus cosine of x, because that's a minus b, times sine squared plus this times this, which would be sine of x cosine of x, plus the last one squared, which is cosine squared x. You run out of room on your paper yet for this problem that you left us space for? We're really getting close now. What can I do now? I have a sine of x minus cosine of x and a sine of x minus cosine of x, so I can cancel that out. And look at what's left on top. Maybe we'll even do this all in one step here. Save ourselves a little bit of paper. Yeah, on the top of what's left, sine squared x plus cosine squared x equals 1. So not only can I cancel that out, but I can put those together, and I can get 1 plus sine of x cosine of x over cosine of x sine of x. And I'm going to put back what this equals now, since we're getting close. We're trying to get 1 plus secant x cosecant x is what we're working towards. And then this is another thing that shows up a while. Usually we're trying to get a common denominator, but now we have a fraction and we don't want a fraction, and so this is what I call undoing a common denominator. If you have a monomial denominator, meaning no addition and subtraction, you can separate that. It's like undoing a common denominator. If you have 2 plus 3 over 5, that's the same as saying 2 over 5 plus 3 over 5. We just normally want to put it together, not break it apart. But if you have things over one denominator, you could separate that as 1 over cosine of x sine of x plus sine of x cosine of x over cosine of x sine of x. Again, I don't know what that's really called, but I call it like undoing a common denominator, like we're separating it back into two fractions. And why would I want to do that? Because I think that gets me to my answer here. Do you agree that this goes to 1? And what about this? 1 over cosine of x sine of x. Is that the same as saying secant of x cosecant of x? It is, because I can bring them up. 1 over cosine is secant, and 1 over sine is cosecant. And yes, it's the opposite way of that they wrote it, but it's addition, so it means the same thing. And I used enough paper, I didn't rewrite it again. Flip it around. That's a crazy one. Probably the craziest proof I've ever done. Especially because it had the difference of 2 cubes in it.
There's honestly no way out there.
Out of control.
I honestly don't know how to get that right ever.
It's okay. It's the only one that's like that. I don't know. I just worked it out. I think like they want to know which one is equivalent to that. Is that the question they asked? Yeah, I got B. I don't know. I just worked it out, and I think I just like they want you to simplify it. And again, 52. And I'll look down really quick, and then that's the last one to do it. I think this is what the problem says, right? On 52. So they want you to simplify it, and again, there's not much you can do here. Because it's not a trig identity, but if you look at the answers, most of them are separated, and so you can do that whole separation thing again. So you can write that as 1 over cosine of x plus sine of x over cosine of x, that whole undoing the common denominator. And then this is just tangent, and what's 1 over cosine? Secant. So again, anytime you see something, just like if you see 2 separate fractions and you want to make it 1 fraction, then you're going to want to get a common denominator. If they give you one big thing and the answers are 2 separate things, then that's when you're going to want to kind of undo that common denominator. And again, it's just something that the more you see it, the more that you recognize what to do there. If you have other questions on this, I'd be happy to answer them in class today. So I have a worksheet for you, but before that, I have a homework quiz for you because we haven't had one in forever. So you need to get out your 5-1 and your 5-2 homework. All of it.
Yeah, 5-1, day 1, and day 2.
Yep. Okay. 28, I just got common denominators and then flipped it up and it canceled out and I got the right answer by just changing all my cotangents to 1 over tangent, getting a common denominator on the top and the bottom and flipping it up. Just like our second example that we did last yesterday. We can look at it at homework list. It's not on homework list.
You got all of our homework?
Yes.
I'll just do that.
It says 5-1 and 5-2 on it. I don't have what dates it is. I just have numbers now, so I don't really know. Because you should, you only did one number, whatever, so you should be able to find it, right? Have a page number. And when you're done, I'll have a worksheet for you. If you have other questions on the homework, it'd be a great time to ask me today. Otherwise, you want to work on the worksheet, and we'll turn it in on Monday. And then on Monday, we're moving on to 5-3. So. I don't think this has yesterday's. Okay, let me know that. So the top 4 you're just copying from your homework, and then the bottom one is one you're going to verify for me. So again, it's a proof, so show me your steps on that bottom one.
How much is it worth?
What, the proof on the bottom?
Yeah.
The whole thing.
The whole thing's worth probably like 20-ish points, and each one's worth 4 points. That's how, I think that's how